Good morning again, everyone. We've got another stalwart from Hursley, John Tilling here, to give us a CICS Foundation update. If you've got any questions, because you're all on mute, just pop them in the chat. And we've got Nick Garrett here as well. Some of you know Nick. Nick will be monitoring the chat. John's quite happy. Any questions, just to pause and answer them. If we need to unmute anybody, I can do that. And I'll probably unmute everybody at the end when we do get to sort of proper questions and answers, but I'm not quite sure about the results of everyone being unmuted. So if you can pop things in the chat, that would be best for us to manage. But without further ado, John, if you can take it away with the CICS Foundation update, please. Thank you.
Okay, thank you, Rob. Well, good morning, good afternoon, good evening, wherever I find you in the world, in case you're remote. My name's John Tilling. I'm CICS Development Lead. And this morning, I'm going to give you a sort of slightly deeper dive on some of the foundational items in the up and coming, well, the already out open beta, which will form the basis of our next release. So I noticed looking at, if we just jump past the standard slides, and let me get rid of participants so I can see the screen properly. Okay, so this is the agenda for this morning. So what's new in the foundational area for CICS Open Beta? Now I mentioned that Mark in his session earlier, or was it yesterday? Yes, I think yesterday, gave you an overview of sort of what's happening with CICS and CD, current release development, and also a high-level overview of what's in the CICS Open Beta. And if you were in the previous session, of course, you've heard all about the security hill that Colin is leading. So I'm going to look specifically at a core foundation. Doesn't include the Java part because that's technically another part of a foundation. So I'm going to be looking at the sort of non-Java core foundation items. And I've had to sort of pick a subset because otherwise we could be here all day because there's a lot of new stuff coming. So I'm going to be talking about new policies, managing temporary storage capacity, some extensions we made to some enhancements we made in 5.6 to do with ZOS shortened storage. I'll talk about enhanced capacity for shared data tables, a couple of CICS DB2 enhancements, and then I'll finish off with some miscellaneous RFEs. So these are RFEs that we nickname quick wins. So these are sort of, as well as sort of the bigger level RFEs, for example, in shared data tables and DB2, these are sort of smaller RFEs that historically they kind of got lost in the backlog and we never quite got round to, but over the last few releases, certainly in version 5, CICS version 5, we've carved out a certain amount of time to address some of these small RFEs. So they might just be, a trivial one that you need a new message for in a certain situation for automation. So it's that sort of thing. So there's a bunch of small odds and sods, if I can call it that. So we'll get to that at the end. So if we start with policy, now there's a number of items we've done in the policy area, and what we did is we talked to the customers on our design council, both remotely through calls like this, and also through our what used to be face-to-face CAF meetings at Hursley, which of course have gone virtual the last year or so. And out of that, you get the customers gave us a sort of prioritized list of policy items. And one of the hottest topics was improving the scope for policy task rules. So the background here is there were a bunch of RFEs that were at least 3, and we had a sizable number of votes on them, and they were all asking for sort of slightly different variations of the same thing, which was basically to make it much easier to be able to scope a policy task rule down to the set of transactions that you want it to apply to, because you might not want it to be applied across the board. or likewise, you might want to exclude a set of transactions. So, and that was quite hard to do. We did have a couple of blogs telling you how you could do this, but we needed a much simpler way of doing this. So we've provided filtering for policy task rules for both the transaction ID and the user ID, and you'll see the screenshots in a minute. So the new filtering is, and I've just spotted here that I've got I thought I'd removed them all. If you see the word Vulkan, that is just our internal code name for the open beta. So that so we've provided this in the open beta. But because this was such a hot one, we decided to backport it. Now, normally we'd probably only backport it one release, but because this was sort of probably the highest voted RFE we had at the time, we decided to backport it to 5.4 and upwards. So you can see the APAR on the screen there. And you also need a level of Explorer to go with that. And you need Explorer 55011 or higher. The latest and greatest just out is 5.5.19. They've slightly changed the numbering system to drop the 0. So 5.5.19 is the latest and greatest as of last week, and it's downward compatible with all CICS releases. But so you need at least 11, or just go and get the latest Explorer to get the policy editor changes. So if we, here's a screenshot. I'm just going to try and get rid of a few things that are blocking my screen. There we go. So here's a screenshot that's showing the new filtering that you can apply to a policy task rule. So you have in the red box there, you can see a transaction ID and a user ID, and you have the ability to say equal, all or equals, or does not equal, or starts with, or does not start with. And that gives you the ability to do wildcarding, both for inclusion and exclusion. And on the next slide, we can see here that the policy editor is actually cognizant of the fact that you specified a filter. And if you do specify a filter, then it will tell you that you need 5.4 or later, because we backported to 5.4 and upwards. If you don't specify a filter, then it would apply to 5.3 because you're not using the new functionality. So that's filtering for policy task rules. Now some new policy task rules. So the first one is to control container storage. Again, this one had quite high votes. So to be able to easily manage that, or perhaps protect against a looping program that's making a request for large amounts of container storage, which can cause problems if you sort of hit mem limit or something like that, because whilst the container is not being used by the application, it's stored above the bar. And so we wanted an easy way to do that. So this one is shipped in the open beta, and we've again backported it, but this time just one release. So you can see the APAR and the Explorer level that you need for the policy editor. And again, if I just show you some screenshots, this is if you're, when you go in and you select that you want to create a new rule, it gives you a list of system rules and task rules, and you can see there's one for container storage. So if you haven't played around with policies, it's really easy. Once you've done it like once or twice, then it's really easy to create new policies, and literally within about 5 minutes you can have a new policy and apply it to your CICS region or set of regions. So here again is just a screenshot showing that we selected the container storage one, and this is the screenshot you'll see in the policy editor, where you can specify the amount of container storage, either in bytes, kilobytes, megabytes, or gigabytes. And again, it's telling you that you need CICS TS 5.6 or higher in order to use this one. So what's tracked in terms of container storage for an application program for the current task? You know, if the application does put container or put 64 or delete container, because of course the amount of storage will go down, or if he's passed a set of containers via a DPL, so he's been linked to, he'll get a channel with a set of containers. So we'll monitor the current task for that. And if he exceeds the limit, that will trigger the policy. And for a started task, of course, you can do start trans ID with a channel with a set of containers, or with the new async API, you can do run trans ID with a channel. And so we'll monitor the started task and you know, trigger the policy if we hit the limit. And the note there at the bottom says that the task rules do not apply to system tasks. This is just for customer user tasks. Moving on again, choosing all requests for some policy task rules. So this is a requirement that came in for the ability to slightly tweak. This particular customer was particularly interested in file requests. And the task rule at present, or prior to this change, allowed you to select a request. And so, for example, say that when a task exceeded 20 read next requests or whatever, you could trigger an event or a message, etc. Now, what they wanted to do was they had a limit, but they wanted to select various of those commands. So perhaps read next and read prev and read but not delete, etc., etc. And so they wanted to select multiple requests. So the way we actually solved this is we went back to the customer and said it was going to get rather messy if we were going to have all sorts of combinations depending on how many requests, whether it's read and write but not browse, etc. And so we talked it through with the customer and said, well, how about we just give you an all option, so all file control requests, would that be acceptable? And it was to the customer, and we thought that was going to be of more general use. It certainly makes the UI changes in the Explorer and the policy editor much simpler. So that's what we've gone with. So as well as the file request policy, we looked at what other policies it would be sensible to apply this to. So of course we have TS requests, we have TD requests, we have storage requests, and also storage allocated, because that policy allows you at the moment to say, well, I want to trigger a policy when the number of bytes of storage in 24-bit storage or 31-bit storage, and so now you could say all storage. So we've applied it to those 1, 2, 3, 4, 5 existing task rules. So you've now just got an all option. And again, for this particular one, because we weren't quite sure how pervasive these changes were going to be, we took the decision to just put it in the open beta. We haven't backported this one. So just a screenshot here. Down the bottom, you can see what it looks like in the policy editor. You now have the option at the bottom, all file commands, or if this was temporary storage, you would say all TS commands. And I'm just showing up top left here what it looks like from a schema point of view. There's an item all is how that maps onto the schema. And the final one, I think, in terms of policy was what oh no, there's one after that. I'm jumping ahead. So the next one is a policy system rule to control the number of transaction dumps as a whole that a particular CICS region is taking. So this came in from a customer. This is a large US customer, and I won't specify any names, but let's just say that they you can work out what arena they're in. They have to vastly overcapacitize their systems to cope with the first 2 minutes of market open on Wall Street. So they have a large amount of capacity to cope with 2 minutes at market open and perhaps at market close. And the rest of the time, they've got a bunch of MIPS to use up. So they unusually run test and production on the same LPAR to soak up that extra capacity in the non-peak times. They allow test regions to run on the same LPAR as production, which is slightly unusual, but I think there are other customers out there might do the same. But of course, you then run the danger of the fact that you've got a road test region that might, potentially hurt the production environment. And this customer was concerned about a test region that was taking a larger number of transaction dumps. And although you can do things with the dump table and dump codes, etc., they wanted a real easier way of just saying, right, this test region, you've had enough, you can't do any more. So we provided the means of setting a threshold for the number of transaction dumps, and then after that they can drive an adapter and they could decide to turn set all the dump codes to 0 or whatever they want to do. So they will get an alert. And they could even have multiple policies. So as they approach the limit, they could start producing a bigger and bigger hammer, and eventually turn everything off if they so wish. So we've shipped this in the open beta, again with the policy editor changes, and we've also backported that to 5.6 via the APAR you can see on the screen, with Explorer this time 55017 or higher. So again, a couple of screenshots, transaction dump threshold, and it just allows you to specify how many total number of transaction dumps you will allow from this region. Fairly straightforward. And I think this is the last one on policy. So what we call the compound condition policy system rule. So this is again as a result of RFEs coming in. At least one, I forget, there might be others, but certainly the main trigger for this was an RFE that came in where a customer wants to be able to trigger when multiple conditions are true. So give you a simple example, when both the MQ connection and the DB2 connection is enabled. Now we have policies already allow you to do those separately, but they wanted to trigger and do something when both the conditions were true. And for this particular customer, their interest was in bundles, and the fact that the bundles are in the right state, because they had a business application. They have hundreds of bundles, and as you're probably aware, bundle install is an async process that goes on beyond the control is given to CICS message. So the fact CICS might be up doesn't necessarily mean your business application is up. And so they wanted to wait until they'd got all their bottles in a row, all their application bundles in the right state, before they would allow work to come into this region. And the way they were going to do that is they were going to use the WLM health capability that we introduced a release or two back. And so the region would come up initially with health of 0, which would cause things like Sysplex distributor to sort of go and find somewhere else to run the work. And what they're going to do is they're going to use this compound condition policy so that when they've got all their bundles in the right state, they will trigger an action. And one of the things you can do on a system rule is to start the WLM health increment. And so CICS will then start incrementing the health value, and it will eventually reach 100%, and then Sysplex distributor will route into that region. So that's one example. There are many examples that customers will come up with in terms of using this capability. So again, here's a couple of screenshots from the policy editor. You can see in the group of system rules, we have a compound condition. And on the right-hand side, these are we went through all the stuff that we allow today through single policies. And worked out which ones would be sensible to allow in this new multiple condition or compound condition policy. So bundle enable, bundle available, DB2, DB control, MQ connection status, file open, file enable, and then pipeline enables state, program enable state, and some connectivity IPIC and MRO. So those are the set of conditions. And then if I move on again, this is what it looks like in the policy editor. And hopefully you can see my mouse on the screen here. I'm pointing on the right-hand side. You can see a plus button there, and you can add conditions here. So in this example, I've got a file open status and a program enabled status. But you could add multiple instances of the same one. So you could have multiple file open requests, or in that particular customer's case, multiple bundle enable status. And you can add as many, there's no limit, you can add as many conditions if you like, as you like. And then you can set your action to what's to happen when the policy triggers. And you can see the one down the bottom there, set ZOS WLM open status. And in this particular case, the customer would say, set it open. So the compound condition rule is slightly unusual in that as soon as it is installed, we will evaluate all the conditions in the policy, and then we will monitor it. If there are some that are still haven't been satisfied, we'll wait until they have been satisfied, and then we'll trigger the policy. And finally, in the policy section, this is just an example of an existing message that comes out and how it looks when you have a compound condition rule. It will tell you the name of the rule and the number of conditions in that rule. And this example, my colleague Jenny created a test one with 2 conditions, so it's saying that the 2 conditions have been met. So with that, I'm going to sort of pause for breath, take a swig of water, and ask Nick, are there any questions so far?
Hi, John. Thank you for that. Currently, there are no questions in the chat, so I'll just take the opportunity to reiterate for the latecomers that if you wish to lodge a question, please put it into the little chat box, and at little pauses that John has through his presentation will bring up your question and endeavour to answer it as well, if we're really lucky. Yeah. Okay, John, I'll hand back to you.
Okay, thanks, Nick. So the next brief topic is managing temporary storage capacity. So again, as a result of some RFEs, this RFE wanted to be able to take action before they exhausted auxiliary temporary storage. So they wanted the ability to be warned when we're approaching capacity. So CICS has solved this. Rather than have a policy for this, because we already have the existing policy rule applying to messages. So what we've done is we've enhanced this area of CICS to produce some new messages. As the TS 1316 comes out, or when 75% or more of the max aux temporary storage is in use, and I think every 5% it will issue another message to say it's got to 80, 85, etc. And on the way down, we just issue one message when the storage falls below 70%, because we didn't want to flood the console with lots of messages if you're sort of toggling in around 70, 80%. So we've took the decision to just put the one message out when you fall below 70%. So with the new messages, you can use the existing policy message rule to trigger on that, and perhaps invoke an adapter to go do something. So as well as that, we introduced some new statistics for aux TS storage to give current and peak percentage. The new stats are available just in open beta. but this capability, the new messages minus the stats, we did actually backport to 5.6 via the 8PAR that you can see on the screen. Now, to go with that, we also did an enhancement to produce some messages for shared TS. So there was a couple of existing messages which gave you a clue but didn't give you the capability that the customer wanted. So we've got some new messages that likewise, like the previous slide, will give you a percentage of when you're both the number of entries or the number of elements in use is approaching the limit of the pool structure. And again, we backported that via the 8PAR number you can see on the screen. And finally, in the area of TS, expiry interval processing. A few releases back, we released or gave you the ability to expire temporary storage, and we tweaked it slightly again, allowing you to specify an interval in minutes. But recently, we've had some cases where we've been having some adverse performance problems to do with expiry interval, and so we took the decision to look at this and solve it. We've done a number of changes in this area. First of all, we treat the scan of local TSQs separate from the scan of TSQs. Prior to this point, there was sort of, it would work out a scan interval, which is normally the larger of either 1 minute or 10% of the smallest expiry interval. But prior to this change, we were applying that both to local queues and shared queues. So now we do a separate calculation for local and a separate calculation for shared TS. So it means that that scanning can be happening at different times. The second enhancement is to solve the problem that if you've got shared TS, then you could have multiple regions all trying to do the same thing at the same time and get rid of expired queues, which is pretty inefficient. You only need one guy to do it. And so we've changed the algorithm to write some sort of, if you like, metadata out to a shared queue, which we call DF shared, concatenated with the pool name. And we write some information out to hold when the last scan was done. And so multiple regions can look at that data and so avoid all doing the same thing at the same time. So it'll mean that the queues will only get scanned at once per minute across the whole set of regions. And the last change that we did was correct an inadvertent change that we'd made when we were enhancing the CICS MQ bridge. And Rob, you'll remember this. We made some enhancements to the CICS MQ bridge to improve what's called route mem processing. And as part of that change, we had to introduce a TS model. And the TS model had a non-zero expiry interval min, number of minutes, which meant that unfortunately customers who weren't using the bridge were suffering from the fact that all of a sudden this new TS model with a non-zero expiry int min was causing lots of scans to happen. Now, with the benefit of hindsight, that MQ change, we should have done it slightly differently. So instead of having a definition in the standard DFH MQ group, we should probably have auto-installed it and only done it when you started the MQ bridge. But that's water under the bridge, so we have to solve it. So the way we've done it is we've changed CICS so that he will dynamically, when CICS comes up, change that CKBR TS model to have an expiry interval of 0. And only if the MQ bridge is started will we revert back to the value that we previously used. So that will avoid customers who are not using the MQ bridge from suffering from unexpected scanning. So down the bottom of the slide, you can see that we've decided to backport this. Certainly the MQ change is already out there via APAR 40409. That one closed in the last week or so. The TS scanning one is due to be backported to 5.6. It's on the backlog, so I would expect that over the next few weeks. So I will move on again, and then Nick, any questions on that?
No, you're being perfectly clear, and no one has any questions.
Okay, we'll move on as time is we're already half an hour in. So extended ZOS storage SOS support. So in 5.6, we enhanced Storage Manager to monitor the use of ZOS storage as well as the CICS managed storage, because as you're well aware, we've had short-term storage capability for decades in CICS, but we haven't had it for ZOS or MVS storage. What used to be called the OS core value, the amount of storage left when you take the CICS DSAs out in the region for use by operating system services, and these days things like JVMs and other stuff. So we put that capability in 5.6, but what we didn't have time to do in 5.6 was to include notification of that to other CICS domains. So in 5.6, we have new messages that come out that you can monitor, but we didn't tap the other domains on the shoulder. So that's what we've done in open beta. So because there is stuff that particular domains can do. So for example, the US domain and the RS domain are notified of these MVS shortened storage conditions. So the US domain, in cahoots with the XS domain, which is security, will free up ACEs and other control blocks if we're short on 31-bit storage. So these ACEs typically stay around and are only deleted when you exceed the USR delay parameter that you specify in the SIT. But if we're actually short on ZOS or MVS 31-bit storage, we will preempt that and immediately free them. In terms of the region status domain, that is used for CICSplex SM, and in terms of its Sysplex optimized workload management, so that CPSM has up-to-date information on the load on the systems. And as you're probably well aware, if you use CPSM, CPSM already factors CICS SOS conditions into its routing algorithms. So for example, if a CICS is dumping or it's short on storage or it's at max task, etc., it will probably go choose a different AOR to send the work to. So we've changed it so that now he can take account of MVS SOS conditions as well as CICS SOS conditions and factor that into its routing algorithm in the same way as it does for CICS SOS. And finally, the other change we did was for the non-Sysplex optimized CPSM WLM, which doesn't use the region status domain. It will react to the new messages that were put out as part of 5.6, and he will factor those in and use it in the same way as he would have done information from the region status domain. He will factor that information into the routing algorithms he uses. So that's a brief one. So I'll move on a bit and then perhaps pause in a few minutes for technical questions. So enhanced shared data tables. This is a pictorial view just to, I'm sure you're well aware, but if you're using shared data tables. So in a traditional sense, prior to shared data tables and prior to RLS, of course, if you wanted to share files, you had a file owning region. So the application would function ship to the file owning region, which would own the file, and it would talk to vSAB, etc. With shared data tables, which of course has been around a good number of years, we have application owning regions that can use cross-memory services into a file owning region, which has got a bunch of storage associated with it, which is holding your customer data, so that we don't have to, if it's for read, we don't have to go read the data off disk via vSAM. So if you were able to, if you like, figuratively speaking, open the bonnet and have a look under the bonnet of what was happening for shared data tables, the way it's implemented in Turning CICS is there are a number of data spaces, 31-bit data spaces. So on the right-hand side of the slide, you can see that there are data spaces named DFH DT 3 through up to 100. So there were 98 up to 98 data spaces you could use for your actual data. And then CICS itself was using 2 data spaces to hold what's called, if you like, metadata. So the index information it required, and things called entry descriptors and backout elements if you needed to back out. So the problem that the customer who came in with this RFE was experiencing was the fact that they had a capacity issue in they were running out of space in these two control regions, DT001 and DT002 data spaces. So the maximum number of records per region is limited by this data table space, the amount of space, and the limit depends on the key size of the vSAM records. So to give you an example, if you had a 45-byte key, then you're limited to approximately 36 million records before you run out of that control data space. And similarly for the index nodes, there was a limit of around about 100 million. So this particular customer had huge amounts of data they wanted to put in the data tables, and they had lots of small records, and they effectively hit the limit when they'd only filled up about 4 or 5 or maybe 6 of the data spaces in terms of their actual data, but they run out of the control data space. So the way we're fixing this, and we're fixing it in open beta, this one won't be backported because there are too many changes involved. We've taken the decision to store that metadata rather than in a data space, but in 64-bit storage. So on the left-hand side, you can see that what was in DT001 and DT002 are now held in 64-bit storage. Your customer data is still in 31-bit data spaces, but now we've given back those 2 data spaces we were using, and so now you can have 100 data spaces for your actual data, which gives you 200 gig per FOR. So we've delivered this in open beta. As Mark probably explains yesterday, we're giving or dropping new refreshes of the open beta roughly every 3 months. There's one gone out in October, and the October one certainly has this item completed. So DT001 and DT002 have been removed as a result of moving the data to 64-bit, and now they're available for your customer data. We've introduced a new SIP parameter, SDT mem limit, to limit the amount of overall mem limit you specify for the CICS region that is allowed to be consumed by this shared data tables metadata. And we allow you to set that. There is a hard maximum of 40% of mem limit, so we won't allow this metadata to consume more than 40% of the overall mem limit. But you can set that below that, and you have inquire and set capability in, and the ability to actually increase it should you be approaching that limit. So we have new messages that come out if you are approaching the SDT mem limit in similar ways that we saw earlier to do with TS. This one's for shared DT. And if you're approaching the maximum amount of metadata specified by SDT mem limit, we will warn you. So before I move on again, I'll quickly check in with Nick to say, are there any questions?
No, just checked and there's nothing come up yet. So let's hear about CICS and DB2.
Okay, so a couple of enhancements in the CICS DB2 arena. The first one is to solve what's called the diamond deadlock problem. And this one has been around for a good number of years. We sort of had a wish to fix this, but it's never quite made it up to the top of the priority list. What it has now, excuse me, while I take a sip of water. So just to briefly describe what the diamond deadlock problem is. Let's say we have 3 CICS regions. So CICS 1, DPLs, non-sync on return to CICS 2, invokes a program that updates DB2, comes back to CICS 1, and we haven't sync pointed because it's non-sync on return. And then that application DPLs to the other CICS 3, who also talks to DB2. So now you've got 2 threads from 2 different regions. And as far as CICS is concerned, they're in the same unit of work. DB2 doesn't know that. He just sees 2 threads. And so he will lock one thread out from the other because he's not aware that they're all part of the same unit of work. And so you'll deadlock yourself if you try and update the same data. Or, for example, if one CICS region tries to read the data that was being written by the other CICS region, he won't find it. So that's the sort of diamond deadlock problem. And the way we're solving it is we're going to pass an XID to DB2. So the XID, DB2's had this capability for a number of years. Outside of CICS, and the XID might be used for recovery purposes. We don't need it for recovery purposes. We have all that capability already inside CICS with Recovery Manager and all the resync and in doubts and all the stuff that you know about. But we're just using the XID as effectively a token to DB2, so that if 2 threads pass the same XID to DB2, DB2 will know that they're part of the same unit of work, and so he will share the locks. Now, we pass the XID to DB2 via what's called a sign-on call when processing the first request in a UOW. The sign-on is what's called a partial sign-on, unless we also have to change the auth ID, in which case it would be a full sign-on. If you're not using DB2 accounting options, and you turn on this new capability, this will involve an extra partial sign-on that you weren't previously experiencing. So there is a small overhead there. But if you, for example, had a count rec UOW on your DB2 entries that say I want to cut an accounting record in DB2 for every unit of work, then you're already doing partial sign-ons per unit of work, and so there's effectively no extra overhead for you. Under the covers, CICS has to do some extra work as well. He has to issue a call to RRS to see if there is an RRS unit of work active, and that does add overhead. So, and the final thing to say there in red is that there is some functionality that is not supported with it if you turn on this new capability, and that is the existing held cursor support. A held cursor, if you're not familiar, is a DB2 concept where you can open a cursor for hold and then do fetch, 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 fetch. And then if you sync point, the held cursor is still there, and you can do fetch, fetch, fetch in the next unit of work, and it's still positioned it from where you last were. That support is not provided if you turn on this XID support, because a sign-on, which we have to do for every unit of work, will actually kill the cursor. So that's the sort of, we document that and say, note, this is a limitation on that. So this, I mentioned earlier that we've had a wish list to do this for a while, but it came up via a European customer with a very hot requirement, and we decided to do it for them. And we've enabled it in current releases through a feature toggle. So by default, it's off. So people have to opt into this. And there's a new feature toggle called com-ibm kix.db2.sharelocks equals true. And that will apply across the board. When we get to, I see another instance of Vulkan here. And when we get to open beta, we've removed that feature toggle and made it a slightly more granular option, in that we've added a new sharelocks option on the DB2 entry as the way to opt into this. So in the same way as today, if you want, for example, protected threads, you have to opt into that by creating a DB2 entry with a protected thread number on it. With CICS Open Beta, if you want this new capability, you have to have a DB2 entry, and you have to say sharelocks yes on that DB2 entry. And that sharelocks option is supported in all the standard ways of defining an entry: CEDA, CSD, UP, CPSM, etc. The default is no, so you have to opt into it. And all the standard inquire and set and stats, etc., have been updated to report the new option and what the setting is. So that's XID support. The second DB2 enhancement came in from a Canadian customer, I think the government of Quebec, and they had a security audit request, in that they need to track information. The topology here was ZOS Connect talking into CICS, then talking to DB2, and they needed to track the requests coming in and be able to track back where requests came from, who touched what data in DB2. Now they could do that today via offline via SMF records, because, for example, what's called the ZOS Connect tracking tokens that are available in the ZOS Connect SMF 126 record is passed into CICS, and CICS will write that in its 110 records. And so if you were processing SMF records today via CICS PA or something like that, you can correlate a DB2 record with a CICS record with an SMF 126 from ZOS Connect. But the requirement was they needed to do this in real time while the application was still running. And the missing piece of the jigsaw was the fact that the ZOS Connect tokens that CICS will eventually write in its 110 record, but only at end of task, they wanted that passed into DB2 at runtime so that they could query it through DB2 special registers. So we've done that. So CICS detects when what's called the origin data has adapter data passed into it. So that's the case when you're connecting into CICS from ZOS Connect, or if you trigger tasks through the MQ bridge or the trigger monitor, there is what's called adapter data present in the origin data that CICS will eventually harden out to SMF. So if CICS DB2 attach will actually detect that there is adapter data present, he will pass extra data to DB2 when we do a sign-on. And that data will eventually find its way out into DB2 SMF records, but it is also available at runtime through these special registers in the center of the slide there. You can see current client Apple name and current client accounting. So this is available via APAR. You can see on the screen there, and it also requires a DB2 APAR 31447. So with 9 minutes to go, I better rush on with miscellaneous RFEs, and then I'll come back and ask for any more questions. So these are bits and pieces, small RFEs that we've done along the way. So again, I think this one might have been you, Rob. add the protect and no check option to start channel. When we enhanced the exec start to enable you to specify channel, we didn't allow you to, at the time, to specify the no check or the protect options. So we've plugged that gap, and so now that's supported. This one came in from an IMS customer who was using CICS and IMS, and they were using IMS XRF, and they had a particular situation where in a failover situation, there was a race condition going on, and they couldn't purge the CICS tasks using IMS. Now, historically, we haven't allowed purge or force purge because it causes problems for IMS. But in this particular scenario, because IMS is failing anyway, we're trying to fail over, it was safe to allow a purge or force purge in that situation. So we've allowed it through in that very limited case. Another one, assign invoking program. Well, as the name suggests, allows you to see who called you. If a DPL request, so if you DPL from region A to region B, and you issue this in region B, you can find out the name of the program in region A. And if you went more than one hop, so you went from A to B to C, and then issued a assign invoking program, all it would do is tell you that the mirror was in region B was the invoking program, which is kind of true, but not what you really wanted. You wanted the name of the program in region A, and so we've altered that so that we will propagate the original program across the hops. So no matter how many hops you have, you'll be able to get back to the original guy. Another one to do with origin data. This came in from a US customer to do with the fact that they wanted to set origin data, and you can do that via a global user exit, XA, PA, DMGR, where you can set data that's going to be present in the origin data. But for this particular customer, it was driven, the exit is driven too early because they wanted to set origin data that was coming in via HTTP headers, which was they didn't get to until after the exit was invoked. And so we've allowed a new exec set association user core data to allow you to specify that data. You can specify an exec capable global user exit that's driven later in the processing than XAPA DMGR. And moving on again, this one I think was a French customer. This one's quite a niche solution, but we previously allowed them to do what's called path aliasing processing for VSAM datasets. So you're probably aware, if you've played around with VSAM, that you can have a path, a VSAM path, and normally a path is defined over an AIX to get to a base. It's a way of having an alternate index path, alternate key. But this particular customer wasn't, this was just a path directly over a base, and they weren't using it for additional key capability. They were just using it as an alias. So, for example, in all their JCL, they would use a generic alias name, and then the base name would have the specific CICS release in it, which meant when they moved CICS releases, they didn't have to change any of their JCL. They just changed the aliasing. And so we'd previously allowed them, or made some enhancements, I think in 5.6, to allow this to be applied to the CSD, the catalogs and intra and temp. But we missed one. They wanted it also for the EYDU rep CPSM repository. So we've added that one in open beta. Inquire feature key. So I've talked already about feature toggles as the way of sort of turning on new function, and you can inquire on them. The actual verb is called inquire feature key, and we support that via CPSM base tables and via Explorer. but this particular customer wanted to know where the toggle came from. So we now report the full path name of the ZFS file that picked up the toggle. Inquire storage 64. So this is, we already have an inquire storage command, and we've produced a new one for 64-bit storage variant. So you can now inquire on a particular piece of 64-bit storage, or get a list of 64-bit storage that has been allocated to a particular task. That one came in from an ISV. Set XML transform. I'm not quite sure why this. We just didn't fix this as an APAR because it's a bug rather than an RFE. The set XML transform command requires you to specify a schema, and if you didn't specify it, it just came back normal, which was a bit useless because it hadn't done anything. So we've corrected that, and so it now produces an INVREC with a REST 2 of 8 saying you haven't specified a schema. Daisy chaining of non-terminal starts. This came in from a European customer who'd got their own user-written routing program that was daisy chaining, going from region A to B to C, etc. And technically, we didn't support that, except embarrassingly, they found that it did work for APPC, but not for MRO or IPIC. And so the case came in, and we took a look at this, and we thought, oh, that's a surprise, because we didn't think it was supported at all. But after a lot of discussion, we decided that it was safe to do so. And so rather than it working implicitly just for APPC, we've now externalized that. So you set a new field in the routing program com area to say, I want this support, and it will apply equally over MRO, IPIC, and APPC. TCP/IP initialization, we've had a number of RFEs in this area. Basically, after a ZOS IPL, there's a race condition as to who gets up first. So if CICS is initializing ahead of the TCP/IP stack and he tries to talk to it, you've got a fairly interesting message with a fairly interesting return code, and it wasn't obvious what was going on. So rather like Colin was talking earlier in the earlier session about improving messages and giving a more explicit message, we've done the same for this particular case. So there are two new messages that come out depending on whether you're using the default TCP/IP stack or you specified a stack. And it will tell you that it can't be open because it's not available. So, and the user action will suggest you retry. So you won't have to go and spend various minutes trying to work out what the heck that weird return code meant. And I think my last slide, with 1 minute to go, this RFE came in from a customer who wanted to be able to identify in performance records, so via CICS PA, work that come into a region from XKey, and there wasn't an easy way to do that. And what we've done is we've tweaked the origin data. So the origin data has what's called previous hop information. So you have a previous hop count and you have a previous hop tran ID. So if you, with CICS to CICS, if you go DPL from region A to region B, in region B, if you look at the data for the transaction, it'll have a previous hop count of 1, and it'll give you the transaction number of the transaction in region A. But that, of course, didn't apply to XKey. So what we've done in XKey now is to reuse that field, PH Apple ID. So now if you look at the data, if you've got a previous hop count of 1, meaning you've hopped in from, in this case, XKey, but the previous hop tran number is 0, because we haven't got a CICS tran number in XKey, it's just a batch programming. We will actually populate the PH Apple ID field with the XKey job name. And we talked to the CICS PA folks, and they have produced some new views to be able to externalize that as well. So that's an easy way to be able to identify this. Of course, when the transaction is running in CICS, you had that capability anyway, and you could do a CMT inquire X key or an exec CICS inquire X key, and it will show you the running tasks, and it will show you the job name, step name, prop name of the batch job effectively. But once the task finished, we hadn't got that information in the SMF data. So now we have it in the PH Apple ID field. And being 1 minute over, I'm just going to say I've reached the end. So very quickly, Nick, do we have any more questions?
No, we don't, John. That's great presentation. If you just go back one slide and leave the QR code for the feedback, we value the feedback. I'll hand over to Rob to just do the final rites.
Yeah, thanks very much, Nick. I always forget about the feedback. Thank you so much, John. A very good session, which we're used to from you with the foundation. And just a bit of a plug for this afternoon, 2 p.m. We've got Ezra Gross, coming in from the US, and a very interesting session on debugging CICS storage violations. So look forward to seeing you all this afternoon. Thank you for your time, everyone, and see you soon. Cheers.
Thanks, Rob. Thanks, everyone.